All right, let us begin. Good morning, good afternoon, and good evening, depending on where you are as you're watching this webinar. I want to start off by saying thank you for spending the time and joining us for this web session. It is my absolute pleasure to be continuing this series of webinars that ProSoft has been having to try and share some of the problems that we've seen in the field and some of the solutions that we have to said problems. In today's webinar, we're going to be discussing integrating PROFINET and EtherNet IP networks and some of the solutions that we have for that specific problem. Just an outline of what we're going to be discussing today. I'll start off with an introduction. I'll tell you guys a little bit about myself. Then we'll move on to a comparison and an overview of PROFINET and EtherNet IP. We'll talk about some of the reasons for integration, approach to integration. Then I'll give you guys two solution examples before we go into a question and answer session. As I'm going along, if you guys have any questions, please feel free to type them in the chat service. And at the end of the presentation, we'll probably give 5 minutes or so to go through some of the questions. We won't be able to go through all of them, but I'm pretty sure we'll be able to cover a few. All right. So let's kick it off with the introduction. My name is Simon Campbell. I'm a technical support engineer for ProSoft Technology. I've worked for ProSoft for 4.5, going on 5 years now. I mainly operate out of Australia in field applications. So if you're in Australia and you have a problem with a ProSoft device and you need someone to come over and take a look, I'm probably going to be the guy who comes and checks things out. I have experience in both wired and wireless solutions, and I'm also a huge fan of the WWE. So that is me in a nutshell. So now that introduction is out of the way, let's move on to the reason why we're here and talk about an overview of EtherNet IP and PROFINET. And we're going to start off with EtherNet IP. And when we're talking EtherNet IP, we're going to be using two terminologies, client and server, right? We'll talk about an EtherNet IP client being the device that initiates communication, the guy that sends the first message. That's going to be your EtherNet IP client. And we'll talk about EtherNet IP servers, which is the guy who is going to respond to that initial communication from the client. So your client is going to be your initiator and your server is going to be your responder. EtherNet IP is an IEEE protocol using Ethernet structure for industrial communication. So to shorten it off, we just call it EIP, and EIP is widely implemented as CIP, or Common Industrial Protocol. And the two common types of classes that are used on Ethernet IP are Class 3, or explicit messaging, Class 1, implicit messaging. Those are the two commonly used types in CIP. Now, if we move on to explicit CIP, I can actually draw three fundamental properties, or what I consider the three best properties of explicit CIP. The first being it is non-deterministic. What do I mean by it's non-deterministic? Explicit CIP has a certain randomness to it, right? You don't exactly know, the server doesn't exactly know the message that is coming from the client, how much data is going to be requested, what that message is going to require, right? But it knows how to respond. So it has a bit of randomness to it. It is also peer-to-peer in the sense that you are going to have a client communicating with a server, right? I like to say it's somewhat peer-to-peer. Why do I say so? Your individual server can talk to multiple clients. Your individual client can talk to multiple servers. You can actually have advanced devices that can operate as a server communicating to multiple clients or as a client communicating to multiple servers. So it kind of muddies the definition of standard peer-to-peer. But if you're looking at a single communication instance, you're still going to have a client talking to a server, and that is peer-to-peer. Another third property I can pull from explicit CIP is that it is simple. It is just easy to use. It is one device sending a message to the other guy and the other guy responding to said message, right? An example of this would be an Ethernet client is shown by a Rockwell controller communicating with an EIP server or an Ethernet server is shown by a PowerFlex drive. Right? At some point at the start of the day, the controller is going to decide, you know, we need to start working, we need to start operating. So it's going to say at t is equal to 0, I'm going to send a message to my drive and say, I need you to start the motor. Right? And the drive is going to respond to that message with, yes, I'm starting the motor, or yes, the motor has started, or the motor is running. Right? So you're going to have that one-to-one communication. Right? It ends up becoming non-deterministic because this controller is going to be taking a bunch of inputs from the real world. It's going to be looking at what the vibration is, how much current is flowing, how much voltage is being used up by the motor. And something is going to happen, it's going to see that the feed rate is wrong, and then it's going to decide, you know what, I need to stop everything, right? So at some arbitrary time, t is equal to who knows, it's going to send a message to that PowerFlex drive and say, I need you to stop the motor. And the drive is going to respond to that message and say, I have stopped the motor. A real live analogy or a real live example that I can give of explicit messaging would be two individuals communicating in an office, right? You would have John talking to his boss in the morning. So John is going to come in and then he's going to say, good morning, sir. And then his boss is going to reply, good morning, John. Beautiful morning, ain't it? Yes, indeed, it is a beautiful morning, right? So you don't know exactly what message is going to come out. You don't know exactly what message John is going to give, who in this case is the EtherNetIP client, to his boss, the EtherNetIP server. But you do know that based on a specific set of instructions, a specific type of message, your server is going to respond. And the response would have been different, right? Take the same scenario and put the same two individuals in Melbourne. That conversation becomes a little bit different. It's no longer a beautiful morning. It's, oh, the weather today is terrible, right? And the response also becomes different. It could be, oh, yes, I agree. It could also be, I particularly like the rain myself, right? So that conversation between the client and the server can change based on circumstance, hence the non-deterministic nature. And then as I mentioned before, that somewhat peer-to-peer thing is going to come into play when the roles start being reversed, right? What was previously the EtherNetIP client is now the EtherNetIP server, right? Say John did something terrible at work the day before, and his boss is just going to come in and just start giving him information. You did this and that and this, so you're fired. And John doesn't even have a second to put in a single word in. All he can do is an action. He can go and get his box and clear his desk and leave. That is a real-world example of explicit CIP communicating back and forth. When we go to implicit now, things are going to become a little bit different. For one, implicit is a bit more deterministic. There's that randomness we're talking about in explicit communication is now taken out, right? We will agree beforehand. I am going to send you 250 integers. I am going to expect that you're going to send me 250 integers back. If you send me more than 250 integers, that is an error. If you send me less, that is a fault, right? And we also agree that I'm going to send you this 250 integers every 50 milliseconds. So we agree on when we're going to be exchanging that data, so it has a periodicity to it. And CIP can also be high bandwidth. Let's go back to the initial example that we had of a Rockwell controller as an EIP client communicating with a PowerFlex drive, right? You can have a single connection, data points being exchanged between the two devices, right? And then you can actually expand that to have a lot more connections, hence that high bandwidth communication, right? Now you have a lot more data. And you'll notice that no matter how the data starts, eventually it's going to synchronize and show you that periodicity. And that periodicity in the communication is very important, but it's something that we'll probably discuss in a different webinar. It's another 30-minute webinar. So we'll leave the topic for now. But it is something that is important. And that is just the basics of EtherNetIP. When you go over to PROFINET, on the other hand, the terminology is the first thing that's going to change. For starters, we are no longer talking about Ethernet IP clients and Ethernet IP servers. We are now talking about PROFINET controllers and PROFINET devices. And that part of the terminology is important to distinguish between your higher level device or your Ethernet IP on Ethernet IP and your higher level device or your PROFINET controller on PROFINET, right? As well as the low level device on Ethernet IP, which is going to be your server, and the low level device on your PROFINET, which is going to be your PROFINET device. Okay, PROFINET is extensively used by Siemens systems, right? And there are three main ways that PROFINET communicates. The first, they call it TCP/IP. That's the one that they use for parameterization and diagnostics. So are you setting a PROFINET IP address? Are you setting a PROFINET name? That is usually done on TCP. They also have what they call real-time cyclic communication, or real-time cyclic data exchanges, which is the more common one that is used, and that's the one that we're going to be talking about today. It is where two devices cyclically exchange data back and forth. There's a third type of communication that they have on PROFINET called asynchronous real-time acyclic communication, or for short IRTA, which is non-deterministic data exchange, similar to what we saw when we're looking at explicit CIP. But it's very rarely used. In fact, now that I think about it, I think I've only seen it being used once in the last 3 years. Not to say it's not important, but we won't be talking about it today because it's just not used very frequently. Right. Now, if we go to RTC communication or real-time communication, I can also pull three fundamental properties. The first being it's deterministic. Right off the bat, we agree I'm going to send you 2 data modules and you're going to send me back 5 data modules. Each data module will have a certain amount of data that we agree on beforehand. It could be 2 bytes, 1 byte, 8 byte, 128 bytes, but we are going to agree beforehand. I'm going to send you 2 modules of data, you're going to send me back 5 modules of data. Or I'm going to send you 5 modules of data and you're going to send me back 1 module of data. And we also agree that we're going to do that exchange every 1 millisecond. So it has periodicity to it. Hence the cyclic term in real-time cyclic communication. Right. And a third property would be it is limited to high bandwidth at very high speeds. Why do I say high to limited high? Because you can actually change the amount of data that you have in a single module and the amount of modules that you can have on a communication. You can actually vary the amount of data from small amounts of data to huge amounts of data. Of course, the speed is going to take a fundamental role because PROFINET is a very fast network with speeds of 1 millisecond data exchanges, which makes it very good for high precision applications. A typical example would be communicating from a PROFINET controller, in this case an S7-1200, to a PROFINET device that is a drive, right? You have a single PROFINET I/O connection and data going back and forth at a period of 1 millisecond. And those data modules would hold varying amounts of bytes of data. Now, if we take these 2 protocols and then we put them against the OSI model, right, just to see where they stand in the standard network model that we're all familiar with, Ethernet IP would probably sit right at the top on the application layer. Why? Because Ethernet IP has every single property of the levels below it. You see session management on Ethernet IP. You see your TCP IP header. And of course, you're going to have your physical network with IP routing and all that down to right on the wire that you have, your Ethernet cable or your wireless radio. Right. You would expect that PROFINET would also sit on the same level of the application layer, but it seems to reside more within that TCP IP stack level. And it gets rid of some of the additional stuff that you would find on the overhead of the application layer. Right. And if we look more closely at RT cyclic and IRT acyclic communication, it actually seems to reside more on the network level. So why is this important? I mentioned that PROFINET is very good for high precision applications because it has high data exchange speeds. And this is possible because of where it sits on the level, allowing it to have faster data exchanges. Right. Not that that's the only advantage that you have with PROFINET, but that's a fundamental reason to go for a PROFINET network. Now, after 16 minutes of talking about PROFINET IP and EtherNet IP, you all be wondering, Simon, this is boring. What is the whole point of learning what PROFINET is, or what EtherNet IP is, or what a client is, or what a controller is? Why do we even need to integrate to begin with? And for that, I'm going to give you guys two examples, right? The first example is going to be a guy named Sally, of course, with the standard movie disclaimer. Based on real-time events, though the names of the individuals have been changed to protect their identity. Let's take Sally for an example. Sally has been working for 10 years at a plant that predominantly uses Rockwell gear. That means he's going to have a lot of EtherNet IP clients and a lot of EtherNet IP servers. He starts looking at his gear and then he realizes, you know, I have an encoder that is not very, very reliable, right? It's not precise. If I change this encoder to an encoder that is more precise, that is more reliable, right? The profits in the company can actually go up. The only problem that he has is his current encoder is an EtherNet IP server. The PROFINET encoder is a PROFINET device on a network that is predominantly EtherNet IP, in which the network controllers are actually EtherNet IP clients. So his problem is, how do I integrate my EtherNet IP clients, which are on a higher level, to my PROFINET devices, which are on a lower level? Now we're going to take a closer look into what solution we gave for Sally. But before we go into Sally, let's look at Jane, right? They had, so Jane's preferred pronoun is they had about the advantages of Rockwell PowerFlex drives over the current Siemens drives that they are using, right? I mean, these Rockwell new PowerFlex drives are amazing. They have vibrational analysis and they link up with the Rockwell's predictive analysis platform and can tell you when your drive is about to fail months before it does. So like any good manager, they go to their superiors, they explain what they found out and all the advantages of these new PowerFlex drives, right? And their superiors allow them to give it a try. But they run into the same problem that we all run into when we're talking about migration, because when you're migrating a solution, you actually need two fundamental resources. You need time and you need money. They have all the time in the world, but they only have budget that is a little over the installation cost of the new PowerFlex drive. And they just can't afford an additional EtherNet IP controller. Right. So what do they want to do? They want to get rid of their current Siemens drive, which is a PROFINET device, and introduce a PowerFlex drive, which happens to be an EtherNet IP server. So you have your PROFINET controllers on the higher level and your EtherNet IP server on the lower level. Again, comes the terminology that I was talking about, where I was saying, let's get familiar with clients and servers and controllers and devices, right? Now you have your PROFINET controllers on the higher level, but an EtherNet IP server on the lower level, right? Before we go into the solution that we have, let's look back at Sally's problem. Remember, Sally wants to connect a PROFINET IO encoder to an EtherNet IP network. So Sally gets a standalone gateway that is going to sit between the EtherNet IP network and the PROFINET device they want to connect to. And that has to be a configurable PROFINET controller. Why? Because EtherNet IP, as I mentioned, is an EtherNet IP set of clients, which is on a higher level than the PROFINET device, which is on the lower level. So they need a PROFINET controller to talk to the PROFINET device. This one device that they get comes with multiple implicit and explicit connection support. It also supports fast RPI connections on Ethernet IP. As an added bonus, it can operate both as a client and as a server. So if they decide that, oh, we actually need our Ethernet IP controllers to become Ethernet IP servers, then that solution would still work, right? On the other hand, on your PROFINET side, you're going to have a solution that has 3,840 bytes input-output that can control as many as 36 devices. Because remember, he's looking at it from the point of profits, right? And if one encoder can work very well, then why not change all the encoders to just become PROFINET encoders? And it also has to support class 1 RTC driver because the devices support class 1 RTC driver. As an added bonus, it gives them that physical segregation where they can literally separate their Ethernet IP network from their PROFINET network, right? Having Ethernet IP clients on the higher level, roles are going to be reversed. Now on the higher level, you actually have PROFINET controllers. So Jane is going to get their own different type of device. A device is going to sit between the PROFINET and the Ethernet IP network. On the Ethernet IP, the device has to be able to support multiple explicit and implicit connections, fast RPI connections to send data back and forth at very high speeds, hence a very high bandwidth, can also operate as a client and a server. In this particular case, we need it to be a client because it has to operate an Ethernet IP server. On the other hand, on PROFINET, you need it to be a PROFINET device. If you can get it to support 1,440 bytes input and output, that'll be good because now you can send a lot more data back and forth between your Rockwell PowerFlex drive or your Rockwell PowerFlex drives and your PROFINET controllers. It also has to be able to support class A on RTC and IRTC communication. Why? Because that is the class of your controllers. As an added advantage, you get that physical segregation between your PROFINET side and your Ethernet IP side. All right. So now in conclusion, let's just talk a little bit about what we've discussed so far. We talked about the differences between PROFINET and Ethernet IP. We talked about terminology, which is important, where we identified Ethernet IP clients and Ethernet IP servers. We also talked about the differences between your PROFINET controllers and your PROFINET devices and how you can connect from a higher level Ethernet IP client to a lower level PROFINET device, or from a higher level PROFINET controller to a lower level Ethernet IP server. So we've crisscrossed that. And that is basic integration of Ethernet IP and PROFINET. So I put aside a little bit of minutes so I could see if there were any questions from anyone in the chat. So if you guys have any questions, please feel free to just type them into the chat. While we're waiting for questions, I will just go, all right, we have one question coming in. Is there any explicit kind of message for PROFINET? Yes, there is. So I did mention that PROFINET supports what they call isochronous real-time communication, or isochronous real-time acyclic communication. That is very similar to explicit messaging on Ethernet IP in the sense that at that specific moment, you can actually send a direct message to your PROFINET device from your PROFINET controller, right, with the same properties as a CIP explicit message. So yes, you can do it with isochronous real-time communication. All right, while we're waiting for more questions, let me go into a little bit of a rant about staged migration, right? Because I think it is very important. If we're going to be talking about migrating, if we're going to be talking about integration, it is very important to talk about migrating, right? When you have a single solution, right? You have a platform that is made of Rockwell devices, right? And someone comes in and tells you about all the advantages that you can actually get switching to a PROFINET platform, or say you have a PROFINET platform and then someone tells you about all the advantages that you get with Rockwell's new technology and you want to switch to an Ethernet IP platform. Right? The best way to go around that is utilizing what we call state migration. State migration being, instead of changing everything one time, you actually change stuff bit by bit by bit. And that's where these two solutions that we're discussing come into play, right? Because they allow you to keep part of your network in one entire architecture while having the other part being totally different. And then with time, you can actually connect these two together. Because again, what you're gonna need when you have migration is both time and money, right? It's very rarely that you would have both. So if you can do your migration in stages utilizing these standalone gateways, you can actually achieve your final goal with minimal time wasted or minimum amount of money wasted. All right. Another question, can we send IRT cyclic messages from 2 PNCs to 1 PND at the same time? The short answer to that would be yes. The long answer would be it ends up being a little bit complicated, right? So what you're going to need on your PND device is a device that can handle multiple simultaneous connections with multiple PNC controllers, right? Usually what you would find on a PROFINET network is that because PROFINET is built on top of the old field bus, right? It would only be designed to communicate one PROFINET controller at a time. Though you have a lot of PROFINET controllers that are able to handle redundancy communication in the same way that you have a lot of PROFINET devices that are able to handle redundancy communication. So as long as your specific device is suited for that communication, you can actually have two acyclic messages going back and forth at the same time. All right. So we don't have any more questions coming in. And I've gone through my rant on stage migration, which I just kept on the side. I'd like to thank you all for joining us for this web session. It is our pleasure to share some of the stuff that we've gone through, and we hope that with each session that we have, you guys learn a little bit more. We're going to keep these sessions coming every now and then. And one last question. Yes, you can get the slides. Those will be arranged by some of our team in marketing. Based on your registrations, I'm pretty sure you're going to get an email with either the PDF version or the PowerPoint version of these slides. All right, that is it. I hope you guys can have a good rest of the day, and let's meet again when we do another one of these webinar sessions. Thank you very much for joining us today.